Hi everyone, I am Sujoy Mahato, currently a postdoc at Harishchandra Research Institute in India. So my poster is about effective gravitational couplings of higher rank supersymmetric gas theories. So we consider a specific type of supersymmetric gas theory, that is n equal to 2 supersymmetric theories, and do a topological twist to this and put it on a curved background. And by this twisting procedure, the theory becomes topological. By that we mean that the correlation function of these theories does not depend upon the background metric on which we put the theory. So if we see the partition function z, it is related to, it has two gravitational coupling, that is this function a and b function. And if you see the exponent chi and sigma, these are Euler number and signature. So these two things are topological invariance of any manifold. So you can see the gravitational coupling is totally topological in nature. So we want to calculate these two function a and b function in great detail. The motivation to study this function was given by Sapiri and Tachikawa in 2008. So what they proposed, that if we think of this supersymmetric gauge theory as a SCFT which lives as a fixed point of the RG flow, so this SCFT has two central charges, and these two central charges can be related to this gravitational coupling function a and b. To be more specific, the R charge of these two function can be related to the central charges of this SCFT. So this is an indirect method to find the central charges of this kind of SCFTs. So with that motivation, we want to study this function a and b. So from symmetry arguments for n equal to 2 theories, this a and b function you can see can be written, has to be in this form as written in equation 1. So we want to verify equation 1. So we study the left hand side of this equation using supersymmetric localization, and we study the right hand side of this equation using the another method by which supersymmetric gas theories are studied, that is the Seiberg-Witten geometries. And once we have results on both sides, we can match the dynamical part and we can see exactly this relation hold, except that if you see both this equation have two constant alpha and beta, and these two constants are independent of the dynamics and cannot be fixed by this general symmetry argument. So we have to go to specific theories and we need to study the how this alpha and beta constant varies with the different parameters of the supersymmetric gas theory, and that is important to know the whole function a and b to write down the R charges for them. And the important result we have found this for n equal to 2 star theories with UN gauge group, we have found this function alpha and beta, how they vary with this function rank of the gauge group. Similarly, we have studied this UN gauge theory with fundamental matter and Kaluza-Klein type of gas theories with fundamental matter as well, and we have found the alpha and beta function for them also. So these are the main result we have found, except also we have also verified this relation holds, and then we have found this function. To more, if you want to know more about these things, please feel free to visit my poster. Thank you.